Hello grade 8s, this is Mr. Miller and welcome to lesson 8.2 on multiplying integers. So we're looking at some multiplication statements that are being represented by arrows on number lines. We'd like to know what each one is. So the first one, you can see that we have 1, 2, 3, 4, 5. So we are adding together 5 groups of size positive 2 each for a total value of positive 10. Now in the second one, there are only 2 arrows. And just because they're going to the left, it doesn't mean that we're not adding their values together. We are. It's just that they're negative each. So we are adding together 2 arrows of size negative 4 each for a total value of, right there, negative 8. Now the next one, there is a correction to be done on the handout, so if you could just shorten the length of that arrow to go only to negative 7, there's supposed to be a single arrow going from 0 to negative 7, and that's why we have this negative 7 here. So one single arrow of size negative 7 has a total value of negative 7. Go figure. Now what you'll notice with these arrows on the number lines is that we are only able to represent a positive times a positive times a negative. I guess you could do a negative times a positive because multiplying A times B, B times A, so the order of multiplication doesn't really matter. But it doesn't really make sense to talk about taking away arrows or having negative arrows. I mean, or a negative number of arrows. Arrows can have a value that's negative, but we can't have a negative number of arrows. That doesn't really make a lot of sense. So we can really only do positive times positive times negative, and negative times positive, but we can't do negative times negative with this particular model. So I just wanted to point that out in case you were not aware. In any case, we can certainly figure out, since a positive times a negative is a negative, if you add a negative times a negative, it should be the opposite. So it should be a positive result. We already had looked at the multiplication rules from before, so now we'd just like to calculate, not worry about the arrow diagrams anymore at this point. We'd just like to calculate, knowing our rules for the signs and just doing the multiplications. So positive 12 times positive 3, a positive times a positive is a positive, and 12 times 3 is going to be 36. Second one, a negative times a negative is a positive, and 8 times 6 is 48. A negative times a positive is a negative, and 9 times 7 is 63. That's negative 63 in this case. And negative 10 times 0, of course, is 0. So now taking a look at the next question, we would like to list the numbers whose product is, so we want 2 integers whose product is negative 20. We want to list all possible multiplication statements. So here is one, starting off with the simplest. Of course, 1 will go into 20 times, and a positive times a negative will give you a negative. But also a negative times a positive will also give you a negative. So there are 2 possibilities. Now as well as 1 going into 20, so does 2. So positive 2 times negative 10 would give us negative 20. And also negative 2 times positive 10 would give us negative 20. And as well, there is also 4 will go into 25 times. Positive 4 times negative 5 is negative 20. And now switching the signs, negative 4 times positive 5 will also give us negative 20. So now taking a look at a hockey problem. It says here in hockey, a plus is awarded every time you're on the ice for a goal that your team scores, and a minus is given every time you're on the ice when the other team scores. So for 8 straight games, Cassie has been on the ice when opponents scored 2 goals. The question is, what is her plus minus score? So this is an application of integers. So since it was 8 straight games, we're going to add together 8 times -2, because she got a 2 minus each one of those games. And the combined effect is that she's going to end up with a plus minus of -16. And next it says we have the sum of 2 integers is -8. Their product is 7. What are the 2 integers? So if we start with a product, we may look at this. We may say, well, +7 is equal to +1 times +7. Yeah, but +1 plus +7 is +8, not -8, which is what we're looking for. So you can also get +7 by doing -1 times -7. And note that in this case, -1 plus -7 does add to -8, which is what we're looking for. So that means that the integers that we're looking for are -1 and -7. And that concludes this lesson. Thanks for watching and have a great day.